So here's our first order linear difference equation. X sub n is the term in the sequence. X sub n plus 1 is the next term in the sequence. So we get the next term by taking the last term, multiplying by a constant, and adding b. We found the equilibrium of that sequence to be b over 1 minus a. And in an earlier video, we solved this difference equation so that we could get the nth term by just plugging in, by getting it directly. We didn't have to get all the terms in the sequence. We could jump right to the nth term with our formula here. And we saw that that equilibrium was stable if the magnitude of a, the number you multiply by, is a fraction, and it's unstable if it's not a fraction. Okay. But let's get back to actual personal finance. So I've got 3 examples here. We can go over and use this equation. Again, what we're getting here is, we're making a lot of assumptions that the A and the B in the equation will remain constant. They're constant in the math, but we're assuming that they're constants in our examples. So this is a back of the envelope style calculation. So let's do our first question. Get the annual return on a fund, an investment fund, is 6%, and I invest $2,000 every year. How much will I have in 20 years? Okay. And I'm assuming that I start with the first $2,000. So when I put the first $2,000 in, that's X naught. So X sub 0, X naught. So my assumption is that X naught is equal to 2,000. So I walk in, start the fund with 2,000. Now I need to know what's my A and what's my B. Well, however much money I have, so I need to know my first order difference equation that's governing this. So whatever money I have in the account, it's going to grow by 6%, and then I'm going to put in the $2,000. So if it grows by 6%, I'm multiplying my money by 1.06. The 1 keeps the original money that I have. The 0.06 is the interest. So I take the X sub n, the amount of money I have, multiply it by 1.06, and add 2,000. That'll be how much money I have the next year. So I've got my A, 1.06, and my B, 2,000. I could get the equilibrium here, but the equilibrium is going to be, well, B over 1 minus A. The equilibrium is going to be a negative number in this case. Mathematically, it makes sense. Personal finance-wise, in this example, doesn't make sense. So I know my A and my B. Let's get our, we can solve then. So here's our solution to this. Our A is 1.06. Our B is 2,000. So I'm filling in all the values, the A and the B that we have. Okay, so I filled in, the X naught. The X naught is the 2,000. I'm assuming I'm starting with that. So the only thing I don't have here is, well, I don't have the X sub n subbed in, and I don't have the N. What's my actual question? How much money will I, or in 20 years? So I have the N, it's 20. So I'm making 20 investments of, so in 20 years. Now there's a little bit, I got to be careful here. Since I started off with X naught and I made N equal 20, I'm making 21 payments, sort of, because I started off seeding the fund with the extra 2,000. So I'm making these, I'm putting in for 20 years, but it's 21 payments. So that would be what, if it was 2,000 times 21, that'd be like what, $42,000. But I'm making interest. My first 2,000 that I put in and all those earlier 2,000s that I put in, they grow at 6%. So it should be more than that 42. What is it? Oh yeah, it's way more. It's almost 80,000. So back of the envelope calculation, this will give me in 20 years about $80,000. Let's do another example. So how long is it going to take me to pay off a loan of $40,000? The loan charges 7% annual interest, and I pay $3,600 a year. The first thing to check is 7% of 40,000. That's going to be what, 2,800. So I'm paying more than the interest. So eventually, it should get paid off. I'm going to use the same equations here. So I want to figure out what my A and my B is. So let's figure out what happens with the money. Well, I got to think about what happens when. I'm going to assume that the bank charges me the 7% interest first, and then it takes my payment into account. So it takes my loan amount, X sub n is my loan amount, and it multiplies it by 1.07. And then in the investment example, I added to the amount. In this case, I'm paying the debt down, so I'm subtracting 3,600. So my B is negative 3,600. So in this case, there actually would be an equilibrium. Now that equilibrium, B over 1 minus, well, let's figure it out. That equilibrium should be B over 1 minus A. So B is negative 36, 1 minus A. If I were to solve this, yeah, that's an equilibrium amount. If my loan was that amount, then my 3,600 would be exactly the interest, and the loan would stay at that 51,429 amount. I would forever. It would be an equilibrium. It would be an unstable equilibrium because the A value is not a fraction. The A value, the 1.07, has magnitude bigger than 1. So what does that mean? That means that if you were to be perturbed from that equilibrium, in other words, if I paid $3,603, I made an extra tiny $3, that would disturb the equilibrium, and eventually I would pay off the loan. Or if I paid a little bit less one year, I could only manage $3,580 or something, then the loan would grow off to infinity. But anyway, we're not asking that. We want to know how long will it take me to pay off. So I'm going to go to that solution again. And I know what my A is. It's 1.07. I know what my B is. Oh, this B over 1 minus A, that's the equilibrium value. So you could replace the B with minus 3,600 and the A with 1.07, or I could replace the equilibrium values here with just that 5,100 and 429, since I know what that value is. Oh, I just need to know X naught. X naught was the original loan amount. That was the 40,000. Okay, and I'm trying to solve for N because I want to know how many payments I have to make, how many years I have to pay this off. What's X sub N? I've still got two variables here. Well, I want X sub N to be 0. I want to make my final payment of $3,600, and then the amount the next time would be 0. So, see, now I got to think about what I mean by N. So I'm going to set that equal to 0, and that'll be and then solve for N. So I'm going to solve this numerically. It's going to take 23 payments to pay that off, more than 22 payments. Now, how would you solve this if you couldn't just highlight and click solve? You'd eventually have to get 1.07 to the N equals a number, and then take the ln of both sides, or the logarithmic, or log of both sides, something like that. So this is saying that N of 22, at 22 payments in, I would still owe some money, and the 23rd payment would be less than that $3,600 then. Again, this is back of the envelope style calculation. It's giving me that sort of ballpark figures. Okay, one more. Retirement fund valued at $800,000. It's going to earn 5% annually. How much annual income can this produce if it's supposed to last 25 years? Now, if it's making 5% annual, 10% annual would be 80,000, so 5% would be half of that. It could put out $40,000 and never diminish. But that's not the maximum that it could put out. If I know I'm going to live another 25 years, I could have it sort of just expire when I expired, I guess. So let's express this as a first order linear difference equation where x sub n is the amount in the account. So x naught is equal to that 800,000. That's what it starts out with. Now, what happens to my money? Well, here I got to think, what's the order? Do I take out the annual income and then I get the 5%, or do I get the 5% and then take out the annual income? I'm going to make the assumption that I take it out at the beginning of the year. So this X naught, or sorry, what happens to my money then? So we got to be a little bit more careful here because I'm considering the order as taking out the money first. So my annual income, I need a letter for that. I'm going to make that M for money. So what happens to my money? This is how much my fund is, and then I subtract M from it because I take out my annual salary, and then the fund makes 5%, so I multiply that by 1.05. And that would be equal to how much money the fund has at the next year. So the X sub n then is before I take my money out first, and then the rest, the leftovers, the difference, that gets multiplied by the 1.05. That's what makes the interest. So now if I compare this, the A is still the 1.05. If there's an equilibrium, well, there is an equilibrium, it's an unstable equilibrium. But my B is going to be minus 1.05 M, where M is my annual income. So now let's get our solution to this. See, without this solution, I'd have to play around with a spreadsheet and keep changing M and try to figure out when this, X of 25 ends at 0. So B is minus 1.05 times M. So I'm replacing in for B. A is 1.05, just matching, templating on my AX of N plus B formula. M is what I'm going to solve for. My X naught is the 800,000. And A, and I want this to last 25 years. So I need 25 payments of that. And that X sub 25, I want that to be 0. Again, this is a back of the envelope style calculation. What are we concerning ourselves with? Back of the envelope style calculation, I'm assuming that I'm getting 5% every year and I'm taking out the same amount every year. Excuse me, and then I'm living to be 24. I want it to last 25 years. All I got to do now is solve for M. Now, if it just put out the 5%, we got 40,000. So it should be a number bigger than 40,000. Yeah, 54,000. So 800,000 can last 25 years at making 5%, it can put out an income of 54,000, and right at the end you die 25 years and your retirement fund is at zero. Anyway, again, back of the envelope style calculation. The nice thing is that this linear first order difference equation is very useful for quickly calculating these type of things.